This is 7.6 factoring ax squared plus bx plus c. So the only difference from 7.5 to 7.6 is this a in the front. So the leading coefficient is not 1 in this case. So to factor polynomials where a is not 1, which is this ax squared plus bx plus c, look for the greatest common factor of the terms of the polynomial, then factor further if possible. So we are going to factor 5x squared plus 15x plus 10. 5, 15, and 10 all have a common factor of 5. So the first thing you're going to check is to see, is this leading coefficient the greatest common factor? If it is, great. That makes it pretty easy. And now we can factor this polynomial just like we did in 7.5. So I'm thinking I need the numbers to multiply to 2 and add to 3. So that would be 2 and 1. And so we're going to factor that. And then if you were to solve, you'd take this, set it equal to 0, solve for x, and take this binomial, set it equal to 0, solve for x. So we're going to factor 8x squared minus 56 plus 48. 8 is the common factor between all three of those numbers, so I put it on the outside. And then numbers that multiply to 6 but add to negative 7. So they need to have the same sign because this plus tells us that. And they both need to be negative because there's a negative here. So that would be 1 plus 6 makes 7, and if they're both negative, we get negative 7. For 2x squared plus 6x minus 36, again, 2 is the common factor in everything. Numbers that multiply to negative 18. So one has to be positive, one has to be negative, and they need to have a difference of 3 where the larger number is positive. So 6 and 3 make 18. The larger number is 6, and 6 minus 3 is 3. So I'll have x plus 6 and x minus 3. If there is no GCF, we're going to look at the factors of a and c. So that's the factors of the leading coefficient here, and the factors of the c term or the constant at the end. And to do this one, I'm going to make a chart, and it's kind of long. So we're going to have factors of a in the first column, factors of c in the second column. We're going to create a possible factorization, and then I'm going to do the o and I from FOIL to get the middle term. So if I think of 1 and 2, those are factors of 2, I'm going to make 4 sets of that. Then I need to have factors of 7, and 7 is prime, so it's only 1 and 7. To make negative 7, one has to be positive, one has to be negative, and I'm going to put all combinations that I can have. In this second column, order does matter. So I have positive 1, negative 7, negative 1, positive 7. Then I'm going to switch them, negative 7, positive 1, and positive 7, negative 1. And to get the possible factorization, this first number is my first x, so 1 and 1. Second number is my second x, the coefficients. So this is 2x here. Then I have the first plus, so plus 1, and the second plus, which in this case is minus 7. So that's how you set them up. And then we have, to get the middle term, we're doing the outside and the inside in FOIL. So that is, we have x times negative 7 is the outside to make negative 7x. And the inside is 1 times 2x to make positive 2x. 7x plus 2x is negative 5. Negative 5 matches the middle term that I have here. So this is my possible factorization. So this is going to be my answer. But if you want to see what happens if I didn't have this combination first, I would have to go through the other possible combinations and see that they don't match. And so x plus 1 times 2x minus 7 is the answer. Now we're going to factor 4x squared minus 19x minus 5. So I have my 4 columns. Possible factors of 4. 4 is not prime, so I have a few options. I have 2 and 2, and I put that twice because it's not going to matter because it's the same thing. And so when it's the same thing, you only have to put it twice, because if I switch it, and then when I multiply it, it would be the same. So the order won't matter when these are the same. Then I have 1 and 4, and I have to put those 4 times, because the order in column 2 will matter. So to make -5, I have 1 and 5. One has to be positive, one has to be negative. And so I have -1 times positive 5, -5 times positive 1, positive 1 times -5, -1 times positive 5. And so I have to go through all possible combinations for each different line that I have in my first column. Now, using the same pattern that I did here, first x, second x, first plus, second plus, I get my possible factorization. First x is 2x, second x is 2x. First plus, I have the -1, second plus, I have +5. Now to do the outside, you have 2x times 5 makes 10x, and the inside is -1 times 2x to make -2x. 10 minus 2x is 8x. That's not the same. So let's switch it and see. Usually when you switch it, it's going to end up as whatever this one is, but the opposite sign. And so if you're thinking, oh, I know that it's not positive 8x and it's not negative 8x here, you can skip this one and try a different combination. So here I'm going to try first x plus times second x, and then first plus and second plus. And -5x plus 4x makes -1x. That's not going to work. So if I switch it, I will get positive x, and that's not the match either. So let's keep going. I still have 1 and 4, 5 and -1 here, and that would be -x plus 20x makes positive 19x. That's close, that's the right coefficient, but the sign is not correct. And so if I switch it, I get the right answer. So my answer is x minus 5 times 4x plus 1.